Okay, now there's special cases, and the special case where the inflow rate equals the outflow rate, which is one of the easier cases you can deal with. The one I just mentioned is a tough one. Okay? Not that tough, but may be hard to integrate. Then you have concentration, which we might as well call C, at rate R, coming in. And going out, you have whatever at rate R, right? Then you have your volume. And if the inflow rate and outflow rates of solution are equal, then the volume is constant. Okay? So you got inflow rate CR, what's your outflow rate? Well, at any given time, what's your concentration in the container?
Q divided by your volume?
Yeah, very good. Okay? Simple separable equation, easy to integrate. So I'll just say that's separable and straightforward. Now, once you integrate this, what are you trying to find?
R.
Trying to find the time. Well, you're trying to find, you're trying to find R such that after a given amount of time, the concentration is a given amount, right? So, you find Q of T. And then evaluate your unknown parameters in terms of the given conditions. Okay? Now I'm not going to tell you how to finish the problem that we're looking at, but once you integrate this and write out your Q of T, then you torture that Q of T into whatever it takes to satisfy the condition. In the case of your problem, you want to know the rate that gets a given concentration after a given amount of time, right? So you solve the problem, you see how the rate influences how the concentration develops. Okay? And it should be clear that if you're looking for a greater concentration, which I hope you are because you're not going to get a lesser, well, actually you could, depending whatever the concentration is at the beginning. Okay? Now, actually, was there concentration at the beginning in that problem?
It had 5%.
Yeah. So, you know, if this concentration is less than the initial concentration in here, then you're going to be looking for a lower concentration. You're going to be diluting your solution, right? And if your initial concentration is lower than the concentration of the inflow, you're going to be looking for the time it takes to get to a greater concentration. Fairly straightforward after you get this once you think about it. Okay? But this is just, you know, one example of a case where these rates are constant. Then you might think about, well, now what if this rate is different than this rate, which is a more general situation. And then we start throwing all kinds of twists and turns into the problems, okay? And they get much harder fairly quickly.